When you think of Taiwan, you probably picture these lush green mountains, right? Maybe some crazy typhoons and a ton of rain. But what if I told you that this subtropical paradise is hiding a pretty serious secret? It's kind of becoming a tinderbox. And today, we're going to uncover this surprising and growing threat of wildfires. Okay, so let's just dive right in with a really shocking event from May 2021. A massive forest fire broke out in Mount Jade National Park. And get this, it took 2 weeks, over 900 people, and 160 tons of water to finally get it under control. It was one of the costliest fires in Taiwan's history. So that brings up the big question we're tackling today. How on earth does a rainforest burn? All right, let's start digging into that paradox. Is this incredibly lush island secretly a tinderbox, just waiting for a spark? Well, the data tells a really surprising story. So here you can see the stark contrast between what we think we know and what's actually happening. On the one hand, you've got the popular image, green, rainy, super humid. But the hard data? It tells a completely different story. Most of these wildfires aren't happening all over the island. They're packed into specific areas during very specific times of the year. And the pattern is incredibly specific. If you look at the data going all the way back to 1964, you see these fires are not random at all. They are heavily concentrated in the southwestern parts of the island. And they don't happen during the hot, steamy summers. Nope. They peak during the dry seasons, winter and spring. So we've got a location and a time. Now we just need to figure out why. So if we've got the where and the when, what's the motive? Let's treat this kind of like a detective story. Researchers have been uncovering a whole series of climate clues to solve the mystery of Taiwan's burning forests. And here is the first huge plot twist. In so many parts of the world, wildfires are all about extreme heat waves. But in Taiwan, the key finding is that temperature isn't the main driver. The real culprits? Low rainfall and low humidity. It's all about the lack of water. So, just how critical is this water problem? Let's look at the numbers. In years with only mild fire activity, the average groundwater storage is at a pretty healthy 45.2%. Let's call that our baseline. But in years with severe wildfire outbreaks, that number absolutely plummets to just 17.2%. I mean, that is a massive drop. And that, right there, is the smoking gun. It shows us that a deep, long-lasting drought is the critical setup for these fires. This brings us to the next set of clues. See, it's not just about a couple of dry weeks. The landscape itself has what scientists call a long memory of drought, where the effects just build up over a really long time. So the crucial thing to understand is how this risk builds. A dry summer and fall, when Taiwan is supposed to get all its monsoon and typhoon rain, drains the groundwater. This creates the perfect setup, what scientists call antecedent conditions. It basically primes the landscape to burn, jacking up the fire risk up to 9 or even 12 months later in the spring. And this leads to this really fascinating kind of counterintuitive idea called the fuel paradox. You would think a wet season would lower the fire risk, right? Well, not exactly. A really wet pre-season can actually cause way more vegetation to grow. Then, when a drought inevitably follows, all that extra growth dies off and becomes tons and tons of fuel, which can dramatically increase a fire's potential size and intensity. Okay, so we've gathered the clues. It's about long-term drought, drained groundwater, and this tricky fuel paradox. Now let's get to the climax of this whole investigation, the forecast for Taiwan's future. Based on all this evidence, scientists have run the models to project what could happen under different climate change scenarios. The verdict is in, and honestly, the forecast is deeply concerning. This chart basically shows the two paths ahead of us. On the left, you have a future where we take major action to limit emissions. That's called RCP 2.6. In that scenario, wildfire occurrences could actually drop by about 12%. But on the right, that's a business as usual, high emissions world called RCP 8.5. In that case, they're projected to increase by a staggering 35.6% by the end of the century. But it gets even more specific and even more alarming. Let's zero in on that super vulnerable southwestern region during its peak fire season in the spring. Under that same high emission scenario, the wildfire potential is projected to just skyrocket by 90.6%. And for the winter fire season in that exact same region, the projected increase is still a massive 51.8%.
I mean, these numbers really do paint a stark picture of a future with way more frequent and intense fire seasons if emissions keep going unchecked.
So, what can actually be done? This brings us to our final section. Because this science isn't just about scary predictions, it's being used to build real systems for protection and public engagement. In response to all these findings, Taiwan's Forestry Administration has completely upgraded its wildfire risk system. It works in 4 key steps. First, they analyze all the climate data. Second, they feed it into a risk model called the Fire Weather Index. Third, they generate a 7-day forecast. And fourth, and this is the crucial part, they send out public safety alerts. And this is really where the science hits the real world. This isn't just some academic paper sitting on a shelf. This research is the actual engine behind a real-time warning system. It translates all that complex climate science into simple, actionable alerts sent right to people's phones via cell broadcast. It empowers people in high-risk areas with the knowledge to be extra careful. It's a direct line from prediction to public protection. Which brings us to our final thought. The science gives us a forecast. It gives us a clear warning of a potential future and the tools to prepare and alert the public. But how we respond to that warning, both as individuals and as a global community, well, that is ultimately up to us.